And I also want to mention, for the purpose of this video, there is a small but real chance that maybe we can't cover the whole question in the time that we have left. I'll simply re-record the video for the whole thing and post that. Okay? Just in case we can't finish this question today. Make sense? Okay, let's do it. So for this one, it's okay if you just sit back and just absorb, because I'll post the video of me solving it. So what we have here is a 2-span beam, 3 supports, span 1, span 2, AB, BC. Span AB has a point load of 10, whatever units, kips. Span 2 does not have a load on it. This question is asking you to draw the shear and bending moment diagram. And the only way to do it is to find the reactions first. Make sense? Okay, so let's do that. First things first, reactions, that means free body diagram. So I'm going to sketch my free body diagram here on that sketch. That's AY, AX, BY, CY. Make sense? Now, I did sketch AX, but is it fair to say that you can tell me what it is? How much is AX?
0.
Make sense? Because there is no horizontal force or component. And then I'm going to do my 3 equations of equilibrium according to statics. Sum of the forces in the x direction equals to 0. And that tells us, like you just told me, AX equals to 0. Sum of the forces in the y direction equals to 0. And that tells me that these 3 reactions and that vertical force have to balance out. So that's going to be AY plus BY plus CY minus 10 equals to 0. Or a nicer way to say that is AY, BY, and CY have to balance out 10. Have to equal to 10. Make sense? We can't do anything else with this, so we take this equation and park it. Call it, say, equation 1. And then our next, third equilibrium equation is sum of the moments at a location equals to 0. I typically recommend picking one of the supports to do your moments about. This time we have 3. A, B, C. Do you have a preference as to what support to do?
B.
Did you just say B?
Yeah.
Why not? Let's do that. Sum of the moments with respect to B equals to 0. So here is the location of my moment, and now I have to figure out the moment caused by all of these forces with respect to B. I'll do it left to right. AX goes through B. That means the distance between AX and B is 0. It doesn't cause a moment. AY, distance between vertical force AY and horizontal distance B is 8, right? AY times 8. And is this a positive or negative moment?
Negative.
It's the opposite of that, huh? So this is a negative moment. Beautiful. Okay, left to right, 10. 10 is at a distance of 4 with respect to B. Positive moment. So that's 10 times 4, and that's a positive moment. B does not cause a moment. BY does not cause a moment because the distance is 0 with respect to B. And then there is CY. It's going to be CY times a distance of 8 And is this moment positive or negative?
Positive. Negative. Positive. Positive.
It is this direction. Positive, right? Because with respect to B, CY is going up. So if it's going up with respect to B, right, it wants to rotate with respect to B. So it's going that way. So it is positive. All of this equal to 0. I think we can make this look a bit better. We can put 40 on this side. It becomes negative. And then on this side, we have AY times 8. And CY times 8. And I guess we can simplify even more and get rid of the 8s, huh? Because if we divide both sides by 8, that's 5, right? Did I guess correctly? 5?
That's a moment. 40.
This here is a 4. Yep.
Yeah.
Yeah. So this is, say, kip feet. If we divide it by 8 feet, it becomes kips. Which is okay, because the 8 disappears from here and you're just left with the forces. Yeah, beautiful. So we can rewrite this as minus AY plus CY equals 5. And this here is equation 2, because we can't do anything else with this. Thank you. And now we're at our usual spot. We have 3 equations and 1, 2, 3, 4 unknowns. Or we can look at it as 2 equations and 1, 2, 3 unknowns, right? No matter how you look at it, we're missing an equation. Okay? So the next step then is find the inflection points. Basically, our virtual hinges. Okay? And we're going to use the second rule, the one that relates to intermediate supports. We have an intermediate support right here because the beam continues on one side and there's another support. The beam continues on one side, there is another support. And do you remember what the number was or what the fraction was? It was L over something.
8.
So for intermediate support, IP at L over 8. Now the thing about an intermediate support is this. By definition, it has 2 sides. So it could be L over 8 on this side, or it could be L over 8 on this side, or both. How do we pick the correct side? It's the side that has a force. Okay? So in this case, only this side of B has a force. This side of B does not have a force. That means that the inflection point is only here on that side. Let me say it differently. If there were a force here too, there'd be a force on both sides. That means that here there would be appearing another inflection point. But that's not the case. We only have this side. So L over 8 is only on that side. Yes?
So we have 3 rules where we can find the inflection points, but why? But we can't use rule number 1.
You can, but all it does, all rule number 1 says that you have an inflection point here and here.
Yeah.
Which means that you can do a sum of the moments at those locations.
But we've already done those.
We could, right? We just chose to do it in the middle, which is one of the supports, right? That's basically what it's telling you, that you're allowed to do a moment there. if you chose to do a moment here or there, even though it's a third equation, when you try to solve it, you'll just end up getting circles. So you'll, go ahead.
So it has to be some, like an internal point?
Yes.
So the rule 1 doesn't always help like this?
It doesn't always help. Typically, I end up showing you when it does, but I don't usually test you on it.
Okay, so we're mostly concerned with 2 and 3.
Yeah.
Okay,
Yeah.
thank you.
Yeah.
Even if you took it at the end, you can't really split it anything.
Right, because the other side is missing, right? There's nothing to split on that side. And the other side is the whole beam, right?
So you have to be able to split it?
Yeah.
Okay, thank you.
So the intermediate support is L/8, and in this case, it's only between A and B. And remind me, why is it only on this side here? That's the only side that has a force, okay? So if I were to sketch it, what that would look like is this. I'm going to draw the intermediate support B, like this. Okay, so I'm just showing the intermediate support here at B. This side has an inflection point. This side doesn't. Okay? And this distance here is L divided by 8. So whatever this distance between the supports is, you divide it by 8, that's where your inflection point is.
So if it was right over B, that wouldn't count?
Right. It can't be right over B. Right, because you have to move a certain distance divided by 8. The only way that it would be right over 8 is if it were 0, which makes it the end of the beam.
So,
There's no way this number can be right over B.
no, I'm just stuck on something else. So it has, so L is, that's between the two supports or
Yeah.
between the support
This
and
distance
the,
here.
so does it matter where the force is or no?
No.
So it could be right beside B, but as long as it's favoring that side.
Ah, okay. I think we're talking about a different subject. The subject is the force.
Yeah.
Yeah, so the force can't be over 8, over B.
No,
Because
no, no.
otherwise it's not on either side.
No, but what if it was like just barely on that side? Does that
It's
matter?
on the side. Yeah.
Okay.
Yeah. Yeah. So it cannot be, another way to say it is it cannot be over B. Right?
So it doesn't matter where it is, or as long as it's on one side, it doesn't matter what's going on with the force, how complicated or messy it is.
It could be.
It's always L/8.
Yeah. For the purposes of this method. It's untrue, but for the purposes of our skills, that's enough.
Okay.
Yeah.
So it's roughly good enough. We can figure it out.
Yeah. Okay. So help me out. What is L/8? It's going to be 8 divided by 8 equals to 1. So right here, 1 foot is where the inflection point is.
And it has to be opposite of the support,
I don't understand.
the force. So if it was like pin, does it have to be like opposite?
I really don't understand. Help me out. What is opposite?
So like, let's say the 10 was on the other side.
Like here?
No. Instead of going down, it's going up.
Yeah. It's still a force.
Okay. So like, let's say if B was pinned, it's not a roller.
It can't be pinned because it's not. If it's pinned, it's not a support. A pin is inside the beam. A roller holds up the beam. One is a support. The other one is internal.
Okay, maybe I don't understand this as well as I thought I did.
Let's talk about that separately. Let's finish this. Okay. So what ends up happening now is we have an inflection point right there, or a virtual hinge. That means we can split the beam right there. And when we do, we can figure things out. Okay? So it helps out to see it big picture, where the hinge is. The hinge is right there, right? So we can split it and either take the left side or the right side. And we don't jump right into it, right? We look at it and see what is the best side to pick. If I do this side, I'm going to end up with by and cy in it as unknown reactions. If I do this side, I'm going to end up with ax and ay, which is good because ax I already have. I can figure out what ay is. And once I do that, I put it in here to get cy. And once I do that, I put it in here to get by. Now, you can definitely do this side. It will just be longer, right? So I choose, we're going to split at inflection point and use left hand side. Okay? I'm going to sketch it for you. The sketch looks like this. And I'm exaggerating it on purpose. So this whole distance from A to the inflection point, does it make sense that it's 8 minus 1? 7?
Yeah.
Like that. Which means that the distance from the inflection point to the point load, does it make sense that it's 3? And now, at this inflection point, we also have an x force and a y force. But we don't even really care what they are, because we're just going to do the moment of that inflection point. We never have to calculate them. So that's what I'm going to do. I'm going to do the sum of the moments at the inflection point equals to 0, with this direction being positive. Okay? So I'm going to do the sum of the moments at that inflection point. I'm going to take it left to right. I don't care about ax, it's 0. Ay times a distance of 7. And is that a positive or negative moment?
Negative.
Ay.
Negative.
It's the opposite of that, huh? Yeah. Like this. So that's a negative moment. And then there's the moment caused by 10 times a perpendicular distance of 3.
Positive.
Yeah, I agree. Positive moment. And then all of this equals to 0. And now we can solve for ay. Ay is going to be 30 divided by 7. Or if you want to make it a number, what is it going to be? 4 point something? Did I hear that correctly?
Yes.
Lovely. What does it mean that it's a positive answer? I guessed up. I'm correct in that guess. Now, I can take this and use either equation 1 or 2 and start solving for the unknown reactions. I'm going to take this and I'm going to substitute it into equation 2. For 2, right there, it's minus ay plus cy equals to minus 5. So now this becomes that. So it is minus 4.286 plus cy equals to minus 5. What is the value of cy? Tell me again, what is the value of cy? Positive or negative?
It's positive.
So what does that mean? What direction is CY going in? So CY, for this question, what is CY doing? It's actually trying to hold down the beam. If CY weren't there, this end would lift up. Does that make sense?
No.
Try this way, okay? Let's pretend CY is not there. Let's pretend there is no support there. It's a free end. This is a diving board, right? There's a support here, a support there. You walk, then you jump, and this end springs up or down, and then you dive off of it. If you have a force here, and you're pulling this down, this wants to smile, that means that part there just goes straight up, because there's nothing to hold it down, right? In this case, CY is actually pulling it back down. That's why we get these frowns and smiles, right? Otherwise, it would just be a smile here and go straight up. No inflection points. But in this case, we have a smile, frown, and then back down, right? It's the only way it comes back down to C. Now that we have a value for CY and AY, we can go inside here and solve for that. Sub into 1 to get AY plus BY plus CY equals 10. AY is that, 4.286, plus BY is unknown, plus CY is that. What is the value of BY? Was it going to be 13 and change? Oh no, it's less, way less than that. So this comes on this side, it's negative 6. 6 and change?
6.428.
Judges, do you like that number? Yeah? What does it mean that it's a positive number? In this case, we guessed up, therefore our guess is correct. And look at this. You have solved the reactions for this beam. Approximately. Okay? Now that we have all the reactions, and we know the applied forces everywhere, we can do the shear and bending moment diagrams. How are we doing for time? Do you want to take a break, and then we'll come back and wrap it up? We can finish this question. Is that okay? Okay. So, yeah, I'll leave this up. I'll pause this and then restart it when we finish it up. Is that okay? 10, 15 minutes? Let's do it.